So there shows two trolleys on the front of a trolley A. There is a wooden rod. There's a wooden rod here. And trolley B is initially at rest. And the trolley moves towards the right, enters the modeling clay. The rod enters and slows down, and B starts moving. So if you notice this, it slows down and B starts moving, and then they stick together and continue moving. So there's a process in between. It's a very gradual process. And you see, it's like this: when two things collide, there is a force which this exerts on this, and there is a force which this exerts on this. The forces are equal. So, like if I call this force, if I call the second body, and this has this has B and this is A, then force on B due to A is the rate of change of momentum of B. So VB, final VB minus MBUB, initial momentum by time. Similarly, for the force on A, this is this is that force F on B because of A, and this would have been the force on A because of B. So force on A because of B is the change in momentum of A, because we are applying a force on A, so this thing changes. So it's like this, and this is the relation. Now these two forces are equal and opposite, Newton's laws. So FB is equal to minus FAB, because they if FB is in this direction, minus and but the magnitudes are same. The magnitude is same, because action and reaction, they in opposite direction. So what happens essentially is, uh, now if you notice something, the uh, this this is, if I can write this as F minus AB, and instead of this I can write this, and then I multiplied by T, so it becomes uh, minus FAB into T is equal to MB VB minus MB UB. And then this minus, if I take to the other side, it becomes FAB into T is equal to MB UB minus MB VB. Now this also I can do into T. Both of them are same. So I get a new equation. I get MA VA minus MA UA is equal to MB UB minus MB VB. And if I take this to the other side, this to the other side, I will get this was UA. Sorry, this was UA. This was UB. So this will become MA VA plus MB VB is equal to MB UB plus MA UA. Now this is the conservation of momentum principle, but it has come through three things. It has come through basically this action and reaction, and it has also come through this term. Now notice one thing: the in one the this is the impulse also. This is the impulse also. So the impulse on one is equal to the impulse on the other is negative of that. The values are same. It's just the negative of that. The other thing is the force is also relevant, but the force is dependent on time. So if the time is long, the force is less. Here, that is what is happening. The time it takes to gradually get it slows it down, and then the total force acts. So basically, it's like this: F into T is a product, and if you increase the time, the force goes down. The impulse remains the same. In both the cases, the impulse is same, but the force is going down because you are increasing the time. And if you see this, so the answer to the question was why the force between the trolley is larger in this case, because here the time is being reduced, because there is no rod and modeling clay present. It's very sudden. So if it's very sudden, then this if the time is very less, so the force FBA is MB. This is very less, so this will be very high. Similarly, here this is less, this will be very high. So both these forces will be very high if the time is less, if there's no clear understood rod time. And the impulse remains the same. The rate of change of momentum remains the same. The time, the area of this curve, F into T remains the same. The only thing is you have increased the time, the force will decrease. The rate of change of the momentum will remain the same. The change of momentum will remain. The impulse will remain the same. Everything is same. Only the time is. No, the force is reducing, no? That's what I'm trying to tell you. Okay, and the signs and all